Hi, everyone, and welcome to the first episode of The ARQIV. In this podcast, we're going to be talking about science and technology from an oddly perspective. I'm a science and technology enthusiast, not an actual PhD, so just like our artificial intelligence today, I can make mistakes. This podcast actually came from the curiosity about ideas and tech that may not really be in mainstream media. So I'm talking about things like how big can an animal actually be on Earth, and could there be a real celestial like the one from Marvel Comics in the universe? Is there technology that can be out there that can read my thoughts? So if you're into weird science, I know, that would have been a much cooler name for this podcast, but obviously that one was taken. Then stick around, because for our first episode, I'm going to be digging into the science and tech of the book The Three-Body Problem by Liu Cixin. So stick around. This one's going to be a mind bender, and listen to me do way more mistakes with people's names on this podcast. So, I know you're probably asking, why did I pick the three-body problem to talk about? And the real simple answer is, I'm trying to solve Jay-Z's 99 problems, and I wanted to start with these three. Kidding. It's really because, honestly, when I read this book, and it's been a minute since I've read this book, I've never seen science used this way in a story before. I mean, in the story, you have quantum sabotage, you have dehydrating aliens, planets where checking the weather means flipping a coin and hoping you don't get vaporized. So I had to break it down. And I think that's what's going to make this interesting. I would like to put a note out there. If you have this book in your library and you haven't read this book yet, there are going to be spoilers. Lots of spoilers. Lots and lots of spoilers. So save this video for later if you're interested in how the science and technology work, but I'm letting you know, you've been warned. All right, I want you to imagine this. I want you to picture this with me. Earth picks up a weird radio signal from the stars, and there's a scientist, someone who's lost faith in humanity after surviving the horrors of the Cultural Revolution in China. And this is the person that sends the reply. I know, that's like a really great way to start a story, right? So, she sends this reply, obviously not out of hope, but out of anger, out of despair. She invites the aliens, the Trisolarans, to come take over. And yes, I know that might not be the way you actually say the word, but you're going to hear me say it a lot of different ways throughout this thing, because for some reason I can't get this right. But that's the part of all of this, right? So the Trisolarans who received this message are desperate too. They suffer from a known scientific phenomena called the three-body problem, which I'll get to in a second. Their planet orbits 3 suns. And basically chaos reigns. Sometimes on their planet it's 1,000 degrees, sometimes everything freezes solid. Sometimes basically the laws of physics just, I don't know, take a sick day. So what is the three-body problem anyway? Now, this is why I picked up the book to begin with, because I like problem solving, but this is a real thing. In physics, if you have 3 objects in space, like stars or planets, that are pulling on each other with gravity, there's no actual way to predict exactly how they'll move forever. You can predict it for a short period of time, but forever, just like a marriage, you just never know what's going to happen. Now remember, gravity may be the weakest force, but when the moon pulls on the Earth, it causes tides, and because of the sun's gravity, we have a solar system. If we had another body like a moon, or even crazier, another sun in our orbit pulling and tugging on Earth, it would literally wreak havoc on our planet. So what happened in the book is they try and predict when these gravitational anomalies would happen so they can basically learn to live with them. Kind of like how I live with anxiety to predict when I lose my mind or have my own meltdowns. But the math gets kind of wild, and it's not just hard, it's impossible to solve perfectly. Today, even with our best computers, we can only guess at what happens in a chaotic multi-star system. It's really like trying to predict the path of a drunk mosquito in a hurricane. I don't know who came up with that, but that was actually really funny. Thank you very much. So in the book, the Trisolarans have to live with this chaos every single day. Kind of like when I decided to have kids and wife and 2 dogs. Their planet gets randomly roasted or frozen, so it's really no wonder they want a new home. And in order to survive, they have to do something that is really weird. They dehydrate themselves into little alien raisins and basically wait out the madness. Time for real science talk! Now, one of the more interesting things in the book is that the Trisolarans are an alien race, and we as Earthlings really only think of Earth life. At least I do, because I'm an Earthling. Funny stuff. So, we think of life as being carbon-based and water-loving. But honestly, life can be different. Unimaginable even. I want to take the example tardigrades. If you don't know what it is, kids, look it up. These are microscopic, indestructible little water bears, and there's pictures all over the internet. But they show that life can be way tougher and weirder than we actually think, kind of like the Trisolarans in this book. So one of the big questions I always think about, probably more than I should, is what life outside of Earth would be like. What would it look like? What would it be based on? We all assume that it might look like us, or our worst fears. They might look like aliens, you know, from the movie Aliens. That would not be a good thing. So I hope aliens look more like us, but just in case they don't, just be prepared. The thing is, though, we don't know. And just like the old adage, you don't know until you find out. Yeah, I might have made that one up. So, I guess it's called a new adage now, right? Maybe aliens don't need beaches and oxygen. Maybe they just need a good dry place to take a nap for a few centuries. Until we meet them, we can only imagine. But on that note, let's go back to the story. So, for the Trisolarans, Earth looks like paradise. It's stable, it's predictable, they don't have to turn into dry raisins all the time, so obviously they don't want to just vacation here. They want to move into our neighborhood. But even with the Trisolarans' advanced technology, they still suffer from the distance of space and light travel, which means it will take them a long time to reach Earth if they're traveling at the speed of light. I'm not going to get into that part of it, but by studying Earth from a distance and also getting communications from our angry antagonist, who is basically just telling them how dangerous we are, and they can also see that through how fast human civilization is advancing, and then they realize that if they don't act fast, humanity's rapid technological rise will one day make Earth an unbeatable fortress by the time they arrive. But they have a plan. And their plan includes sending these things called Sophons, which are basically tiny proton-sized computers. And these Sophons, when they're sent to Earth, are supposed to sabotage our scientific progress and freeze us in place. And it's just the beginning. That's what makes this story really cool. So the Trisolarans' fear of humanity and their desperate gamble to stop us with the Sophons sets the entire story in motion, and it's packed with more mind-bending science than a black hole roller coaster. But honestly, to be fair, I don't think I would want to live on their planet, and I would have a backup plan too if I had 3 sons kind of just in the neighborhood causing that kind of havoc. So I feel for them just a little bit. Just a little bit though. All right, now that was kind of the overview of the story, but what the heck is a Sophon? Because that's where it really gets a little weird. In the 3-body problem, a Sophon is a proton. Yeah, it's like the same thing that you see inside an atom. And this Sophon, it's been unfolded into higher dimensions and crammed full of technology. So a Sophon is a small computer that basically folds in dimensional space. Wow. That's weird. So when they fold it in dimensional space, then they can refold it back into the size of our reality. Sure. Okay. Well, getting into the folding and unfolding part later, because that is going to take a minute to explain. But imagine stuffing an entire supercomputer the size of New York City into a marble, and then shrinking that marble down to something smaller than a virus, and boom, that's what your Sophon is. That's one of the things in the story that kind of keep things interesting. These little monsters can spy on scientists, they can disrupt experiments, they can cause flash hallucinations. Flash hallucinations, I think is the best way to say it. They can provide flash hallucinations onto people's brains. And most importantly, they mess up our particle accelerators, which basically means humanity can't discover new physics. We can't build new technologies. We get stuck. Like we're in the 12th grade and just can't seem to graduate because somebody stopped us. That's a really terrible example. Hopefully they get it. Okay, but wait, I know what you're thinking. How can Sophons, these tiny supercomputers that are stuffed into a marble, do all of this stuff? So let's start with Sophons can be everywhere at once. It's also a really good movie. You guys ever seen it? Just saying. So there's a few parts to how the Sophon can be everywhere at once, how it can communicate, how the Trisolarans can communicate from their distance to ours in almost instant communication. We'll cover some of that in the wonderful world of quantum entanglement and texting across space a little later, because that's going to need a minute as well. But here's the cool sci-fi idea. Because the Sophon has access to higher dimensions, it can project itself into multiple places at the exact same time. And there's even an interesting theory about that I'll get into more later as well, because that also needs a minute to unpack. Boy, there's a lot to unpack in this. I hope they're got their seatbelts in, because this is going to be crazy. It's going to be a crazy ride. So think of it like this. Think of it like holding a flashlight, but the beam shows up in a million rooms all at once instead of just showing up in the one room. So basically the Sophon isn't teleporting around super fast, it's existing across many places simultaneously thanks to its higher dimensional structure. So it can spy, interfere, and flash crazy visions, all while just being this little microscopic thing. Real science break number 2. So we can't really build anything like a Sophon yet. That's kind of a cool idea in the book, but scientists are working on quantum computers and nano devices that are so small they can actually work at a near atomic level. You can think of things like some of the microprocessors that have been invented, which we can manipulate at some level or another, not at the quantum level or the small size that the Sophon is, but it's still kind of cool to know that we're near that. And here's another wild science idea that's really sounds like something out of a sci-fi movie. I mentioned earlier that when the Sophon can be everywhere all at once, there's also a weird theory that I found when I was researching this, and it came from a very famous physicist named John Wheeler. He was kind of like a science mentor to Richard Feynman, you know, one of the guys that helped build the atomic bomb. Yeah, heavy stuff. So the theory that John came up with was the one electron universe. Get this. Wheeler wondered, what if every electron in the universe, you know, the electron that's attached to the proton in the atomic stuff you see all the time, hopefully? What if every electron in the universe, the ones in your body, in your pizza, in the sun, is just actually the same electron, just this one electron? But it's moving back and forth through time so fast and so weirdly that it looks like there's a bunch of them. And you may be wondering, you know, how did this guy just sit around and think of that? Because I sometimes do that too, and I can understand, but maybe you don't. It's because every electron is identical. It has the same mass, it has the same electrical charge, there's no difference at all. So it's kind of like somebody wearing the Flash suit, and then you see the Flash suit everywhere all at once, and you're like, that's just one person, right? Hopefully that was a good example. I guess we'll find out in the comments section. So Wheeler joked, as they do in astrophysics, maybe that's because they're all literally the same one. How crazy is that? Here's a simple way to imagine it. Do you like roller coasters? No, I wasn't asking you. I was asking the audience if they like roller coasters. Get with it, dude. Think of a roller coaster that loops through a huge amusement park. Every time the coaster zips by a different spot, it leaves a trail, like a quick photo snapshot. If you only saw the snapshots, you might think there were dozens of roller coasters, but it's really just only one coaster, moving really fast, leaving its trace everywhere. That's kind of the same thing here with the one electron. It could be zigzagging through space and time, and we see it in a lot of different places because of its crazy path. So this connects to the Sophon because in the three-body problem, the Sophons kind of behave the same way. It's this one tiny thing, but it seems to be everywhere at once, messing with experiments, causing chaos. They're not really teleporting, they're not multiplying, they're just operating in higher dimensions, kind of like that one electron might be skipping all over the universe. But there is a bottom line to that. The one electron universe, it's not a proven scientific theory. It's more like an epic science thought experiment. But it's super cool and a way to kind of explain how something small like a Sophon could actually pull off some really big, weird tricks. Okay, hopefully you guys are still watching because this is crazy science and topics. But for the rest of the nerds out there like myself, take a deep breath because we are actually going beyond like normal weird. We're going to go into extra dimensional weird. Remember how the Trisolarans built those Sophons by unfolding a proton into higher dimensions? I told you we'd get back to that. What does that even mean? How does that even work? The universe is such a weird place, and that's why I love it. Imagine you live in a flat 2D world. And I picked up this kind of topic from Neil deGrasse Tyson because he's one of my heroes. If you're watching, give a thumbs up and like. So imagine you live in a flat 2D world. You are like a drawing on a piece of paper. To you, there's only left, right, and up, down, but not like up like you're standing up, just like a flat up. Yes, that's okay. Sure. Now imagine a 3D creature, like a person poking their finger into your 2D paper world. Now to you, that finger would look like a circle appearing out of nowhere. It would look like magic. Now, in the 3-body problem, the aliens basically unfold the proton into higher dimensional space. And it does crazy engineering work when there's basically more room to build. And then it basically folds back down into a 3D world. I always think of it like one of those books that pop open and then close back up again. Are they called pop-up books? That makes sense. Yeah. So yeah, I think of it like a pop-up book. For the real science nerds out there, have you ever seen Doctor Who? Have you ever seen the TARDIS? The one thing they always say, my God, it's bigger on the inside. I love it, but it's the same idea. Extra dimensions folded into normal space. Yeah. There's also this other one, it's called the old paper folding analogy. I don't know why they call it old. I only heard about it a few years ago, so I think it's still pretty young. But the old paper folding analogy, if you folded a piece of paper just 42 times, 42, is there a reason for that? You know, because of the book? If you folded a piece of paper just 42 times, it could theoretically be thick enough to reach the moon. That is crazy. That's some crazy paper. Math is a monster. Real science break number 3. There's an actual physics theory about this called string theory, and it suggests there are 10 or 11 dimensions out there. But most of them are compacted, meaning they're so tightly curled up, we don't even notice them. Physicists have been hunting for evidence of extra dimensions at places like the Large Hadron Collider, where they basically smash particles together so hard that they, reveal hidden dimensions that might get shaken loose. At least that's what they're hoping, and that'd be kind of cool to see as well. Can you imagine if your closet could fold and unfold, the amount of stuff you can get in there? That's crazy. Okay, but it gets even weirder. So we're going to be talking about basically spooky actions and cosmic text messages. I told you we'll get back to that too. Remember when we talked about the Trisolarans communicating with Earth like you were talking to your best friend on your cell phone? Yeah. There really isn't a cell phone plan that's that good where you can talk to aliens across light years of space. But if you do have one, please let me know. I'm in the mood to switch then. So now it gets a little spooky. Literally, because to explain this, even Albert Einstein called this next thing spooky action at a distance. I bet you he really liked Halloween. Not the movie, though. Holiday. Is it a holiday? I don't even know. Okay, so spooky action at a distance. Welcome to the wonderful, weird world of quantum entanglement. Ooh, that's gonna be a long one. Alrighty. Here we go. Picture 2 particles. Let's call them Bob and Alice. If Bob spins one way, let's say Bob spins to the right, and Alice instantly spins the opposite way, let's say to the left. Now, no matter how far apart they are, they could be across the room, across the galaxy, it really doesn't matter. If Bob spins right, Alice will spin left. It's kind of like they have like a secret handshake or telepathy or something, right? But it actually works faster than the speed of light. Yeah, they may be wondering why it's faster than the speed of light when that's the light limit, but in all actuality, there are ways around it. I'm not going to get into all of that today. Maybe. Crazy, right? Even Einstein really didn't like this idea. He thought there had to be something wrong with it, but even Einstein isn't wrong, or is he? Well, we'll find out at some point, I'm sure. But this actually kind of brought into a question that popped into my noggin, is how do these particles get entangled? How does Bob and Alice actually meet? Were they together? Did they have long walks on the beach? Did they just enjoy the presence of their company? Were they soulmates and were they meant to be together? That went a weird direction. Okay. Honestly, there's a lot of hand waving here because even the smartest people don't really fully understand all of the details. But in simple terms, when 2 particles are created together or interact very closely, their properties become linked forever. They're not separate anymore. Kind of like when you get married. I want you to think of it like this. It's like their quantum recipes are baked together. Do you guys have an analogy that might help with that? You're watching the cooking channel. Nice. Let me give it a try. Okay. Think about this tasty idea. Imagine you bake a cake, and it's half chocolate and it's half vanilla. Once it's baked, you can't just lift out the chocolate without lifting out some of the vanilla too. They are fused together. Even if you cut the cake in half and you ship one to New York and one to Tokyo, they still reflect that original connection. Now, quantum entanglement is like that cake. There's no strings, no secret messages, just one shared spooky connection across space and time. Yeah. Real science break number, I forgot. So quantum entanglement is actually real. They've tested it in labs all over the world, and even China has a satellite that managed to beam entangled photons from space to Earth in 2017. But here's an important update since the book was written. Recently, scientists did some experiments using computer simulations and realized that entangled particles don't actually send a message between each other, and there is actually no secret handshake between Bob and Alice. It would have been cool, though, if they had like some weird, like, okay. It's not that Bob and Alice tell each other how to spin, it's that their states are linked from the start. So if Bob were to go right or Alice were to go left, the other person does it the opposite direction. It's just they're linked that way. Nobody really knows how or why. The mystery. Also, in fact, the experiment, the simulation, they ruled out the possibility of there being any hidden messages, anything passing between them at all. But it gets even weirder and stranger because that's where this episode is going, if you're still with me. There have actually been newer quantum experiments, once again through computer simulations, where researchers attempted something called delayed choice entanglement swapping. That's a mouthful. Couldn't they have used something else? In simple terms, imagine you bought a friend a red hat, but later you found out that they actually hate red hats and love blue ones, because who doesn't? In these experiments, it's like you could somehow send information backwards in time to yourself to really change the gift before you ever handed it over so they can actually have the blue hat. Now, some of the quantum experiments showed that under certain conditions, outcomes could be influenced retroactively. I think it was 3 out of 4 times. But this doesn't mean time travel is real. Sorry, Doc Brown. I really did enjoy your movie, though. But it does hint that quantum reality may not care about cause and effect the way our normal brains do. Yeah. Okay, so after all of this quantum weirdness, dimensional folding, and alien strategy, what does the 3-body problem really leave us with? Well, it left me kind of a feeling and a question. What if the universe isn't silent because there's no one out there? What if it's silent because everyone is hiding? In Liu Cicin's vision, survival means staying invisible, staying quiet, not revealing yourself until it's too late. And just maybe, just maybe, the rules of physics aren't fixed after all. Maybe they can't be bent, sabotaged, or hidden like a Sophon whispering through the fabric of reality, but in the end, the 3-body problem reminds us, myself, that science isn't just about the facts and experiments, it's about the wonder, it's about the fear, it's about staring into the dark and wondering who's out there, and are they watching us, or are they already watching us? Thanks for wandering through the strange with me. Keep questioning everything, keep laughing at the chaos, and remember, the universe is a lot weirder and way more wonderful than it actually pretends to be. Please subscribe so I can make more episodes like this, because I've got even more questions that I want to share with all of you.